Hi there, guys. This is a bit of an experiment. Notice the glare in the corner. That's another thing we have to worry about with this whiteboard. Um, I sent you a whole bunch of assignments today, I think 6 or 5. And some being able to do these assignments is definitely based or predicated on a couple of small concepts I'm going to do here, and then a couple problems I'll do on this whiteboard here, and hopefully you'll be able to do it. Notice though that I'll do the problems on video no matter what, but you should be trying to do them on your own, and this hopefully will help some of you come up with the ideas that I'm talking about. So here we go. If we know the circumference in terms of pi of any circle, and circles are part of the volumes, the three-dimensional objects we're doing, then we know the radius. And if we know the radius, then we can calculate any of the things that we've been doing, the radius and the height. So let's just try this little experiment here. Let circumference, just for the sake of argument, equal 50 pi. Notice it works so much better in terms of pi. Otherwise, of course, we need a calculator. And we'll get to that, as I promised. Don't worry. We're on the way to getting there. So I can immediately find what r is if I replace c with 50 pi. And there's the variable r now. Now the variable's not x. You should keep that in mind at all times. Divide both sides by 2 pi. And there we go. Everybody cancels. And then you have 50 divided by 2. And there you have it. What's left? 25 equals r. So you found the radius. So that works as long as you know if you can get the circumference in terms of pi. So that's what your questions are doing in terms of circumference. So you'll be looking at that. Keep that in mind. That will help you on your own solve some of these problems. And the same thing holds true with area. It should be pretty obvious to you that area, of course, equals pi r squared. That was a nonlinear function that we talked about, and that brings us in contact with a math that we have to look at much more closely, but not right now. And we look at this and we say, oh, well, let area, just to make the numbers equal, equal 25 pi. Well, then when I substitute here, I get 25 pi equals pi r squared. And when I divide both sides by pi, we're back again to an old boogeyman that we met so long ago, the perfect squares and radicals. So r squared equals 25, but nobody asked you for r squared. You need to know what r is. So I put the hat on both sides. That's the way we put it back in the day. And the square root of 25, oh, isn't that nice? It's a perfect square, is 5. And the square root of anything squared is that number. We've talked about that so many times. So in this case, the radius is 5. So starting with the area, I found the radius. Starting with the circumference, I found the radius. If I know the radius and the height, or the radius only for a sphere, I'd be able to solve the problem just like I did before. They're just simple equations. An example right away. Let there be some sort of cylinder, and let the circumference equal 20 pi, and just to make the numbers work, let h equal 5. When we're talking in units, we haven't got into conversions or anything like that. So the question is so logical, is find v, the volume. I mean, that's typically what they'd ask you to do. Well, this solution is very easy. First, I need to find r. If I don't know r, then I can't find the volume of this particular figure. I know what the height is, but r, I don't know. Once I find r, then I know v, the volume. Okay? So the problem's simple as you can imagine. So 20 pi equals 2 pi r. I just did that 2 seconds ago. Most of you get the good idea there. I divide both sides by 2 pi. and r equals 10. That is, the radius now equals 10. But now it's just a plug-in problem. Isn't that correct, guys? I just know the radius now, I know the height, and now I can find the volume, and I do that now. I have V equals, I gotta watch the glare here, V equals pi r squared h. Well, that means that V equals pi 10 squared times 5, so that V equals 500 pi, in terms of pi, of course. Now, there's a perfect example of what you can do when you're doing a problem like this. I'll give you a problem with a cone that also does a circumference. And I'll include some of these problems in the next workload, easy ones like this. And I imagine a cone of some sort. And again, I know the circumference is 12 pi. And some little birdie told me the height is 3. And again, with h equaling 3, they want me to find the volume. So I'll just slow up a second, and I'll give you a chance to write that down and see if you can do it really quick, and then I'll do it. Remember that you can only do this for up to like 10 minutes, and then it becomes a big deal uploading it, or whatever that word means. All right? So the circumference is 12 pi, the height is 3. Those of you who understand, you're probably halfway through the problem. Well, C equals 2 pi r. We talked about that. Okay, so that means that 12 pi equals 2 pi r. Well, that means, obviously, doing the same thing for the fourth or fifth time now, that 6 equals r. So the radius is 6. So I fill the radius in here, r equals 6. And now I'm all set to go to finish the problem, and I have V equals 1/3 pi r squared h. One student asked me why it's 1/3. Well, I explained in the previous video that if the height and the radius are the same, you can put a cone snugly inside a cylinder, and it will only take up 1/3 of the space and leave the other third of the cylinder, 2/3 of the cylinder, empty. There'll be a problem on that, and I'll go more into detail. Well, here we go again. It's just a plug-in problem now. V equals 1/3 pi r squared, which is 6, times h. And again, you notice this numbers is set up because we care about the concepts. We're not really concerned that much about number crunching, and isn't that so sweet? The 3's cancel, and there we have the answer without any pain whatsoever. 6 squared being 36, another perfect square that we want to keep in mind, and the volume is 36 pi. Okay, I don't know how long I went on. 8 minutes and 35 seconds, so I've got to turn this off. I'll do some a little later with area, so you can see that this is all making a lot of sense. And the area only works for us, of course, if we keep in mind that we're using perfect squares for now.